last time I presented for this meetup was about 3 years ago when we had it exactly in this room. So as you can imagine, I'm a bit rusty. And the thing is, at the time, I was actually a Kubernetes engineer, which meant I actually used Go. For the last 2.5 years, I basically haven't touched the line of Go. So this was exciting when I found out on Friday that there's a chance that we need to have another talk today. Yes, exactly. So last time I was here, I showed you something about how to use Go to operate drones using Kubernetes. So that's the thing. I'm not a great engineer, but I know how to combine things in really weird ways. So yes, that's the thing. At this point, I don't even know what is my official title or actual any title. Nobody understands what I do. I'm in between SAP, Go, Java, Salesforce, whatever. It's just confusing for everybody. Now, let's try to understand what we're going to do today. And I know you're like, screw it, Go, we can actually use something like Whales or other, let's say, front-end frameworks that we can tack on top, and we can build a Go, that's easy. We can build a game, and that's easy. I'm like, no, because I actually want to focus, and I want to show you something worse. We're going to be doing this on a microcontroller. And that's the reaction I'm actually expecting. It's not full of memes. There's a couple. I told you I'm old school. Time stopped for me. And you'll see this reference a bit later. The amazing thing that I did last time was from the same developers and contributors who built the drivers for operating IoT devices using Go. And one of the guys is called Dead Program on GitHub. I don't know exactly what they do, but one of the last commits on TinyGo is also from them. So you can understand that I'm kind of close to this area of IoT, microcontrollers, and using Go to operate it because it's really easy to write fast code, and you don't need tests because most likely it's going to run, and if it crashes, it's fine. So what is TinyGo? TinyGo is even worse than that because it brings me closer to memory unsafe. Exactly. So what's the terrible thing about writing microcontroller code is that you have to do it usually in C++, C, maybe Rust. My brain doesn't go to Rust. I'm sorry, I tried. We don't agree. We have differences. While when you're telling me that I can tack on top of a microcontroller a garbage collector, interesting. So the thing is, I've seen this presentation of one of the developers of TinyGo, and they're basically compiling your app and the runtime. I think they're going to an AST, and then they're using LLVM to pass that into microcontroller code. So this is my high-level understanding of it. The thing is, it works both for microcontrollers and for WASM. Interesting, because then you can simulate some of the microcontrollers. So also, I've seen that it tends to build really small packages for WASM. So if there's anybody who's interested, have a look at that. That's not my focus. I really want to see how much damage I can do. So we're going to start with a very simple function. It's just a main function. That's nothing weird. We're configuring a display, because we need to have a display for a game. Whatever those bits are doing, I have no idea. Then we're drawing some gophers. That's fine. And now comes this really weird call. The thing is, when you're operating on a microcontroller, it's slightly different than running on a for loop in your normal operating system, because you don't have an operating system. You're actually running on interrupts, and you tie and you hook to these interrupts to perform certain actions. And what this basically does is, when that interrupt happens, it calls my function. So main is kind of interesting, but where the actual stuff is happening is an update. And we're doing a for loop for forever to actually run our application. Cool. Now, you may have heard me before talk about global variables. This is why. So there's some that you might see that it makes sense. We're registering basically the keypad buttons so that I don't always have to name them. So I would say fair game here to put them as global vars. That's OK. The thing is, this is a screenshot from the old one. OK, so actually this one looks relatively normal. So you will actually not going to see the terrible things. These are from the documentation. I could not really change these. I've just understood that this is unsafe. You do this to the pointers, it does something. It works. OK, that's it. And we need the display size because we might run on different types of displays. That's fine. Another important thing to understand that TinyGo, even though it's really a compressed Go you don't have access to the entire standard library. You don't have access to a lot of different packages. You have access to some of them. But the ones you have access to are really important. So we have TinyGo, the main thing where we're going to write our code. We have TinyFont, which is really important because sprites don't work on our microcontroller. And we cannot load images on our microcontroller, which means we need to be creative. And thank God that you have this. So Jana Dogen basically created a font of Gophers. So that's amazing for having a main character, right? Fantastic. And the thing is, you can convert whatever font you want into one that is compatible for the machine. So you can actually kind of use this to hack your way around not having images. So fine. For our purpose, it works. We could probably do everything with fonts, but it is, again, a terrible idea. Let's try to make some sort of an abstraction, like triangles, rectangles, lines. These are kind of useful if you want to build a game, even if it's not a complicated one, OK? So again, most of these things that you see, they're really similar to whatever you know from Adafruit. And whenever you see something with like MicroPython, or you see something with their weird version of C, I think that's what they use for their Arduinos, this is our version of it. This is TinyGo's implementation of it, and it works pretty good. So the start screen. It's not terrible. We're just doing one character per line, OK? So relax. It's not like I'm duplicating code. We're just putting the coordinates of where we want to draw something. You can see the fonts that we're using. And yeah, it's quite simple. So we're going to display Gopher. We're going to display press start and Zürich, because the U with the umlaut doesn't work. I tried. I'm sorry. I wanted to be nice, but no. And yes, again, because of a font, we have J and X, which are the two different types of Gophers that we're going to use. And I've added a rectangle to show it around the screen. Fine. Nothing special. That update function that I was talking about. Now, you have to understand that this is basically the core of our app. Because whenever an interrupt happens, that's about 60 times a second, more or less. And it calls this. What this, OK, the check border, don't think about it. But the idea is that we're trying to understand if within this time, a certain key has been pressed. It's a weird way of doing it. I completely agree. But it works, and not my code. So that I keep. OK, so we go further. What I've changed a bit is this project is based on a blog post. I'll put all the thanks at the end. But the thing is, it was a great proof of concept of how to do this. I just had to tweak it a bit to make it more terrible. And that's the thing. I wrote a very tiny little move function that basically just takes if it's vertical or if it's horizontal, and basically by how much you want to move. And you also need to give it its old values. The old values are important because what we're doing is we're going to be overwriting the old Gopher with a new one of the same color as the screen, so in this case, black. It's important for performance, and you'll see this later. Check border. So this is also something new I've added to the proof of concept. It was like, I want to make it more of a game, not as a proof of concept. So beautiful, I know, right? This is how you how you basically try to compare things. But it fits really well on a slide, so that's not a big problem. The thing is, we need to compensate 40 pixels, because due to the size of a Gopher, I could not predict where it would be exactly. So in order to show you a good collision, that's the buffer. And yes, we do have a kill screen. And that is something I'm really proud of, because it makes it feel like a game to me. It's not Dark Souls level, but we're getting there. And the point is, kill screen will basically rewrite everything that the screen has with a black rectangle. Then on top of that, we have you died, press to restart. And here it's really fun. This is the old version. I've done a couple of changes today. But the point is, I don't really know how to stop it from running. There's no pause. So what I did is basically I just stopped until you click select. So it keeps running until you click select, otherwise it does not continue. Now, I'm not joking. I know it's beautiful to write applications in Go, and And the thing is, you have this time.sleep. I don't. Time does not work on this specific microcontroller. So when you do time.sleep 5 seconds, it just executes the next command. That's why you saw me wait for a second. So I was like, are you kidding me? Let's have a look at what this is. So this is a screenshot of one of those posts. Everything is basically linked. So if you click on it, you're going to go to the actual link and the issues of everything. And I think there's actual issue about this, and it's amazing. And the thing is, I've mentioned before, we have this interrupt that happens 60 times a second. And I wasn't sure how to use this. And today in the morning, I was talking to a colleague of mine. We had our stand-up, and I'm like, yeah, I'm demoing this game, but the problem is I don't have time. Like, I just have something. And she's like, yeah, that's not really a game. I'm like, I absolutely agree with you. What do I do? He's like, but you have that interrupt. I'm like, yes. Why don't you count it? I was like, wow. So the thing is, we have a custom timer now. So we have time. That's important. But because I don't know exactly what that time is, we're going to call it score, because it's a game, so that's relevant. And the thing is, it should work. It more or less works. That's our global variable, and every single time update is called, we do score +1. Again, you see this is like really basic Go code, but the way it gets to work is the fun part. So you've always seen, I'm talking about a microcontroller. Why did you choose one that doesn't have time? You don't support loading images. What's the point? This is why. Now understand my motivation when I figured out that TinyGo supports this. I'm sorry, this is just like, we will persevere. We will find a way to make this work, but we'll find a way to write Go games on a Game Boy. So, let's see. So, the terrible part about Nintendo products is that they are terribly documented. Like, they do proprietary stuff. You're trying your best to try to figure out what they do. There's like pages and pages of documentation, people trying just to reverse engineer this. I am extremely happy the TinyGo team somehow managed to get this working to the level it does. But really, really problematic if you use TinyGo with a Game Boy Advance. Because the problem is, it works, but you don't have like stuff like time, stuff like understanding where you're in, like you have a lot of different interrupts that are happening on the machine, and they're not documented. So you cannot understand which one is actually happening when. So that's why the only one I've used was the v-blank one, because it was the only one I could figure out for something. So this is, by the way, something new I found out. It's called a task file. Again, in 3 years that I've been doing Go, I didn't know that this is a thing. It's kind of like make, but looks nicer. And you install it with brew, like brew install go task. And you just use a YAML, because it's better than XML, to write all of your commands. I was impressed. So the thing is, it works. Now, let's see, what do I have? Yes. Now, let's go to here. We go to, let's just zoom in a bit, and we're going to do task run. No warnings. Right, it works. So we have a Game Boy Advance game called Go for Zürich. Before I'm actually going to show you the final version, now that I'm actually thinking about it, let me show you a bit the iterations, so you also understand my pain. It all started with a V1. Please, oh yeah, because it's in bin. Oh, please, yes. So this is how it was. This was the original game that was built by the blog post that I followed. So really nice. I really liked the fact that it's also in like the Google colors. I was like, OK, this is cool. So we do start. This is the gopher. If I click right, that's how it moves. OK? If I click jump, I mean, don't get me wrong. The person who built this, she's amazing. She put all the work of the TinyGo team to get it to work, so fantastic. But we can take what she's done and bring it a bit like to a different level. So after doing this part, and I knew that this could be workable in an emulator environment, I'm like, OK, we're going to do a V2. So the V2 is basically, I changed a bit the drawing. The drawing was based on a comment on the original post and was like, don't redraw the entire screen when it's moving. Just draw a gopher of the same color of the background, and it should be faster. I'm like, OK. I added Zürich, of course, we had to. I also changed the character there to be a bit more inclusive because I was like, OK, let's do some graphical changes as well. And also, I've added a border, right? So now we kind of know where the collision could happen, right? So now we have, I would say improvement is pretty good. And if you want to jump, like, it doesn't manage to draw that fast. So it actually works. And because I've had the update today about the thing, once you hit the border, you have a score that is actually increasing with time. It looks like nothing, but it was a huge achievement. So this is all cool. This is all fun, OK? But it doesn't really feel like a game because if I click again start, it's like you could sit here. This is not a game. You know, it's like a very nice demo. It's like we go left, we go right, amazing. Yeah, no, we need to make it harder. So how do we make this harder? This is my presentation, is it? Yeah. So I have this amazing colleague, and he has a huge collection of like retro games, and he's really passionate about retro gaming and about building his own stuff. And I was explaining to him that, look, on Monday I have to make this talk for Wednesday. And he's like, if you want to make a game mechanic, do wind. It's very simple. In terms of implementing it, you just need a bit of random movement that comes from one direction, and it will actually create some sort of like player engagement. I'm like, sounds great. So for doing random movement, you need random. Importing math.random overflows my game. Problem. This is my random. Is it great? No. Does it work? Yes. So that's the thing. Whenever this score changes, at one point it will just have a different value. That's good enough for me. And this is a recommendation from a different colleague. And he was like, why don't, by the way, so this feels kind of like really sponsored by Rush because we all gathered together to build this. And we're like, OK, you're doing it, but we're going to give you ideas. So instead of doing standard wind, just increase it with the score, because now we have a score, right? So the more you stay in the game, the harder it gets. I'm like, brilliant. Yes, let's do that. So we've done that. We have random. Oh, yeah, also what helps is the fact that we're increasing the score, but we're also making sure that the game becomes extremely difficult after a point, because otherwise I get an overflow. So now I've actually understood the amazing things of people who are building games back, I don't know when, and when they were optimizing things. If you think a level is too difficult or like the time goes too fast, maybe it was actually a technical decision that pushed them to make the game mechanical. It's honestly, I've had so much fun with this project, and I really haven't been working on what I was supposed to. So this is great. I have that. Before I actually go deeper, so let me just show you what we have right now, right? So we have a V3. V3 Gopher, same thing, nothing special. Please. So you see, he's moving. You can try to maintain it. Yes, he's not. We're trying our best. At one point he hits, collision, you get a score, right? Nice. But the thing is, I'm here, and you're wondering, why do we have this? So the thing is, I do have a Game Boy. And the thing is, I also do have an Easy Flash. So a colleague of mine, as I said, is really interested in video game development. And he likes to do some mods to his games. He has an insane collection. So he has this. And I was like, OK, let's do this. So I have a new SD card. Let's see if I can still do this while being connected to HDMI. This is going to be amazing. So we kill this. We go to Finder. We go to Dev. We go to TinyGBA, bin. And actually, just to prove that we're not doing something wrong, we're just going to do task build. So you can see the output is gopher.gba, OK? So gopher.gba we take. It's here, untitled. We paste it. And now, because I'm a nice person, I'm actually going to eject this. So now, let's see if the second part of the demo works. Now, Apple, please make your technology work for me. OK. And we go here. And we go to File. We go to New Movie Recording. Ooh, OK, that's my camera. That's fine. We want... Oh, please, don't tell me this is not going to work. OK. We're trying this, OK? So maybe when you're tethering, it really doesn't like to do this, because it's been using the same thing. So let's just try to do Google Guest. Oh, by the way, I'm not affiliated with MongoDB in any way. This is just a free hoodie. OK, so let's try again. File, New Movie Recording. Please, iPhone, don't do this to me. Continuity camera. It worked before, so let's just hope. Yes, I want to enable this Wi-Fi. 1 sec. Let's go. We connect to the same Wi-Fi network. We connect to Google something guest. OK, please. I thought this would be so much more straightforward, honest. Oh, wait. OK. OK, this is I'm sorry, Google, if I'm showing your dirty floor. OK, so I'm removing the old SD card that I had just for backup purposes, because as Michael said, you never know when you're going to overwrite these, especially if they were running on drones. So nothing special. So this is the cartridge itself. You place a micro SD card inside. Has some battery. I don't really know how exactly it works. Plug it in. So now, that's the easy Flash software. So technically, we could have done this on an actual cartridge. Unfortunately, even though my colleague has everything, this he does not have. So we're stuck with a micro SD card, OK? And this is our gopher.gba. So I'm going to try my best to kind of center this. And I don't know what I just clicked. Ah, here it is. Yep, OK. Wait. Start. And you see it works much nicer on this thing. It's like, and yes, at one point it just becomes incredibly difficult, but I've got really good at this game, as you can imagine. And I think it actually crashed. Yep. As you can imagine, this is under heavy, heavy development. I'm just going to try my best to just show you the die screen because, again, things happen. So very quick suicide. OK, so it works, OK? So I think that was a demo. I want to say a very big thank you and to acknowledge the people that all of this was done in 2 days only because they helped. So Learning Go by Examples is an amazing guide from Aurélie Vache. She basically did the big part of showing how this is possible, like putting that Gopher on the Game Boy Advance. From then on, I forked her repository, removed whatever other examples they had, and built on top of the game. So the borders, everything that moves. Matthias is the amazing virtualization guy that also has a passion from retro gaming. And Sasha is my colleague that basically fixed the time for me. And now I basically could do both random and time. So honestly, thank God to these guys and to the lady, because otherwise I wouldn't have any presentation today. And this was done in 2 days because short notice presentations exist. Thank you all very much for listening to this. Please enjoy the beers outside. Sorry for being slightly rusty, but I hope you had a lot of fun. So, Michael, sorry, I didn't even notice.